So this is another example for moment area theorem. So determine the deflection at point C of the beam as shown in the figure. So the beam has a uniformly distributed load of 30 kilonewton per meter and then a concentrated load of 55 kilonewtons. So values for E and I constant all throughout the beam from A to C. Okay, so first thing that we need to do is to sketch the elastic curve of the beam. So say this is the elastic curve, and then ang unknown ani is the deflection at point C. So from the figure, this is the elastic curve. Point C of the elastic curve is this one. This is point C of the elastic curve to the original position of point C. This is the deflection at C. So kana siya atong i-determine. Para makuha nato na siya, kailangan ta mag-sketch og tangent lines para makuha tag relationship. Okay, so sketch na to ang mag-sketch tag tangent line tangent to point B of the elastic curve. And then kaning distance is from point C of the elastic curve to the tangent line at point B, or kani siya is equal to the deflection of C relative to tangent line B. And then this angle, kani siyang angle, is the slope at B. So to solve for delta C, or the deflection at point C, based on this triangle, kani siya nga triangle, so natay relationship nga delta slope at point B is equal to opposite delta C plus delta CB over 3, or delta C is equal to 3 theta B minus delta CB. So unsa na to solve si delta B? So i-project na to ni kani nga tangent line at B. Ato siya i-project padulong diri sa leftmost side sa beam. Tapos on the elastic curve at point A to the tangent line at B, kani siya nga measurement is the deflection of A relative to B. Anong kailangan nato na siya? Because kailangan nato ma-solve ang theta B. Kani siya is also theta B. And using this triangle, ma-solve na to si theta B. Ay dayon na to siya magamit diri to solve for delta C. So we have kana itong gamitin ng later na siya. So natay theta B is equal to delta of A relative to B over base na 9. Before ta makaproceed, mag-sketch sa ato ang MEI diagram. But we will use the bending moment diagram by parts kay naatay uniformly distributed load. And para mas easier ang sketch sa ato ang moment diagram. Okay, So mag-select tag reference point. Ang sa kaning problem, pinakasayang nga reference point is kaning sa point B, para walay areas nga mag-cross sa duha ka segment sa AB ug sa BC. So before nato na siya ma-sketch, kailangan ta og reactions at the support RA and RB. Summation of moment at A equal to 0. Assume counterclockwise positive. RB times 9 is equal to 30 times 9 times 4.5 plus 55 times 12. So RB is equal to 30 times 9 plus times 4.5 plus 55 times 12 over 9. 208.333. Then summation of forces along the vertical equal to 0. RA is equal to 30 times 9 plus 55 minus 208.33. RA is equal to 39 plus 55 minus 208.33. 116. .63 kilonewtons. Okay, so we now have the reactions. Ma-sketch na tayo na itong iyang MEI diagram. So, iparotate na to tanan forces about point B. Let's assume that B is fixed. Dayon na siya rotate. So we have RA nga 116.67 times distance para makuha na to ang moment at B. Aning RA. So 116.67 times 9 is 1050.03. Ay. 1050 over EI. Then kanida yon si uniformly distributed load. Para makuha na to yung moment diri nga point, si kani siya, so i-rotate na to about ano. So na din tayo moment at point B. So moment at point B is equal to 30. Ano man si B? Kung left side ini analyze, so ang moment niya is positive moment, MB, counterclockwise. Si 30 kilonewton ang rotation niya is paana. So negative yung value. So ang yahang moment is na diri sa ubos. So negative 30 times 9, 30 times 9 times 4.5 or 1215. Tapos kuan man na siya, uniformly distributed. So ang shear niya is first degree diagonal. So parabolic dayon ang iyahang moment diagram. Okay, so this is 1215 over EI. Dayon, ang last na to nga load is kani si 55. Si 55, kuha na itong moment about point B. So, force times distance, 55 times 3, 165. So, 165. 165 over EI. So, muna siya ang value sa moment at point B of the 55 kilonewton load. So, kompleto na ito ang MEI diagram. We can now proceed in solving for the deflection at C. So, unaw na ito yung solve. Para ma-solve na ito si theta B, so nasa delta AB is equal to x bar integral of m over EI dx from A to B. A to B is kaning duha ka areas. Kaning area o kaning area. So, positive o negative. Equals 1/2, base is 9, height is 1050 over EI times its perpendicular distance about A. Kani siya kay deflection of A relative to B. So, naraman niya siya dire. So, A on the elastic curve, dayon yung tangent line B. So, dire na to sa A, i-base, or dahat na mag-measure sa iyahang moment arm. So, muna iyahang moment arm, or perpendicular distance, which is equal to 2/3 of 9 minus 1/3 base, height is 1215 over EI times perpendicular distance. So, kaning area kani siya measure din sa point B is 1/3. So, padulong sa A is 3/4 base. So, kani siya itong perpendicular distance, 3/4 of 9. Okay, so delta AB 0.5 times 9 times 1050 times 2/3 of 9 minus 1/3, 9 times 1215 times 3 times 9/4, or 3/4 sa 9. 3746.25. So, 3746.25. This is kilonewton meter cube over EI. So, theta B is equal to 3746 over 9 EI equals, so divided by 9, 416.25 over EI, kilonewton meter squared. So, that is theta B. Substitute na to na siya later dire sa atong equation sa delta C. Pero before na to siya substitute, isolve sa nato ni si delta CB. Delta CB is equal to x bar integral m over EI dx from B to C. B to C is kanirang gamay na triangle, kani siya. So, 1/2 triangle man, base is 3, height is 165 over EI. Okay, so times its perpendicular distance measured from point C. Delta CB na siya, no? CB. So, dire na to siya measure sa C, which is equal to kaning nga distance 2/3 of 3. So, times 2/3 of 3. So, this is equal to 1/2 times 3 times 165 times 2/3 of 3. 495 over EI, kilonewton meter cube. So therefore, delta C is equal to 3 theta B minus 3 theta B minus delta CB equals 3 times theta B is 416.25 minus 495 over EI. Delta C is equal to 3 times 416.25 minus 495, 753.75 over EI in kilonewton meter cube. Delta C is equal to 753.75 over 200 times 10 to the power of 6 times 830 times 10 to the negative 6 para may mo siyang meter to the fourth. Delta C therefore is equal to 753.75 over 200 10 to the 6, 830, 10 to the negative 6. This is equal to 0.00454 meters or 4.54 millimeters. Delta C is upward positive. So deflection na siya pasaka. Kapasaka ang beam at point C. Okay, so that's it for moment area method sa aning problem. Let's solve this problem sa katong ikaduha nga method, katong third method, which is the conjugate beam method. Or makita na to ang difference sa iyang computation.